So, the other day we talked about Maclaurin series, yeah? And can somebody give me a clue of what's a Maclaurin series? It's the idea of trying to do what?
Taylor series routes.
Try and fit a polynomial series around 0 to some kind of funky function like sine or cosine, right? Where a polynomial is x to a power, yeah? So Maclaurin is the idea of trying to fit a polynomial around 0. But if I wanted to estimate cosine or sine of 18, well, it would take me forever to get my polynomial to bend that many times so 18 was fitting well, yeah? So instead, instead of around 0, I could fit somewhere closer to 18. It would take me less terms. That's the idea generally of Taylor. The idea that it doesn't have to be around 0, just fitting, that's Taylor. Maclaurin is a special case of Taylor where you're trying specifically to do it at 0, but Taylor is just any old place. Now, the idea is still the same. Each time you have an x to the first, an x to the second, an x cubed, and each time you have a factorial in the... Hi, what? All right, here you go. So, the difference, though, is that because you're not fitting around 0, it's shifted over to fit around C. I mean, don't we horizontally shift something by saying x minus to shift over? Yeah? So it's shifted over. First thing you'll notice that's different is it's shifted over to center around C instead of around 0. I guess you could still think x minus 0 it's there, but we don't write it. Likewise, also different is that instead of the function fitting at 0, I want to fit the function at the C. C stands for center. It's where you're trying to fit. I want the derivative to fit there, the second derivative, or the concavity to fit there, and the third derivative, and so on. So it's still the same idea, but you are fitting around a slightly different point. So far, so good? All right. Now then, say we wanted to estimate cosine of 2 2x. Once with a Maclaurin, which means centered around 0, and then once centered around somewhere else that's closer, right? So do you remember what cosine's Maclaurin is? Think even powers, cosine's even. Do you remember how? You'll get these into memory. Right. 1, and it alternates, so minus x squared over 2 factorial plus x to the 4th over 4 factorial, and that's good for now, all right? You get the idea. We could write the general term, but we don't need to. So far, so good? Now, if I wanted to estimate then cosine of 2, then that means x is being played by 2. So that means what goes into my Maclaurin for x? 2. So I'm going to have 1 minus 2 squared over 2 factorial plus 2 to the 4th over 4 factorial minus 2 to the 6th over 6 factorial plus 2 to the 8th over 8 factorial, and so on, yeah? All right. Now, I think would you write, throw in here, let's say we use the 6th degree Maclaurin. That's what I should have put in. So we wouldn't go through 2 to the 8th, we would just stop at 2 to the 6th, yeah? And remember, we often use a little subscript here on the end. This, I remind you again, that does not represent number of terms. I know this is so confusing, but that is degree. When that number is there for Maclaurin, it's not like partial sums. It's the degree you end at. So 6th degree. You down? You dig? Okay, so that means a 6th degree Maclaurin. 2x to the 6th, or 2 to the 6th. All right, now, I could put that in my calculator. I could get my x. Okay? Maybe we should do that. Should we do that? All right. put that in our calculator and do that. Now it also says, talk about the error bound for your estimate. Now, 1 is 1. What is this equal to, the second term? 4 over 2, so it's 2. This is 16 over 24. Yeah? 2 to the 6th is 64 over, what is that, 720, I think? Yeah? So, before I use error bound, I need to say a few things. What do I need to say? This series is alternating. The limit of the terms is 0. Do the terms go to 0? Are the terms getting smaller and going to 0 eventually? Yeah. And do the terms decrease in absolute value? Yes, when? After 2, for n greater than or equal to 2. Okay, I know they don't decrease the first to the second, but after 2 they do start to decrease, yeah? So it must be the case that, now here's where it'll be a little different than the alternating we're used to. We first need to explain this situation. We're talking about the difference between cosine of 2 and our 6th degree Maclaurin of 2. And that's the same as the difference between the true infinite sum, which we call S, and our partial sum. S of 6? S of 4, because that represents how many terms are added. And that's just so crazy. Less than or equal to what? A5, which is, what's the next term in the pattern? 2 to the 8th. Don't worry about the negative or positive. It's 2 to the 8th over 8 factorial. And whatever that is, that's your error, right? No. What is it? That's the error bound. The error is no more than, that's not the error. That's the point that you know is an upper bound for your error. Your error is no more than that. All right? Okay, now that's still quite a bit of error, especially for sin and cosine. So let's try and do better. Now, a nice number that's close to 2 is pi over 2. It's much closer. Pi over 2 is about 1.57, right? Heck of a lot closer to 2 than 0 is. So let's say we tried to center around pi over 2. Now when I say, just so we're clear, when I say center around pi over 2, then that means we're going to make a line at pi over 2, and then a parabola at pi over 2, and then maybe a cube at pi over 2, and then maybe a 4th degree at pi over 2. And so it's going to gradually fit, but that pi over 2 is a heck of a lot closer to 2, and so we'll get a lot closer, a lot quicker. Yeah? All right, so here it goes. This is where Taylor comes in, because it is not quite the same. So we're going to say that Taylor, did they say what degree? 3rd degree Taylor. So a 3rd degree Taylor for any x, I understand we're centering at pi over 2, but it's at any x that we're doing this, right? Is f at pi over 2 plus f prime at pi over 2 times shifted over, so x minus pi over 2 to the first over 1 factorial. What's the next term? F double at pi over 2 times x minus pi over 2 squared over, and it said 3 there, so I'm good, right? Does that 3 mean 3 terms or 3/3 power? 3/3 power, so I need to keep going. F triple at pi over 2, x minus pi over 2 cubed over 3 factorial. And that's it. All right. Now, I need to in an organized way. You'll definitely get to the point where you do all this stuff, some of this stuff mentally, depending on the problem. But we're going to do this structured. So I need to find f at pi over 2. That's cosine at pi over 2. I find it easiest to write it this way so that as you take derivatives, it's got an x in it, it's easier to take the derivatives down. What's cosine of pi over 2? 0. All right. F prime at pi over 2 is negative sine of x at pi over 2. What's that equal? Negative 1. Oh, I drew this picture bad. Isn't pi over 2 here? Dummy on this. Sorry, you get the idea. Negative 1 slope, right on. All right, f double. What's f double? Negative cosine. And what's f double at pi over 2? 0. And let's do one more. F triple is positive sine at pi over 2, which is 1. Now, we're only going to put in the ones that are not 0. So this guy, f at pi over 2 is 0, so that's not going to show up. And f double at pi over 2 is 0, so that's not going to show up. Instead, all I'll have is negative 1 times x minus pi over 2 to the first over 1 factorial if you like. And then what's your next term? Plus 1 x minus pi over 2 to the third over 3 factorial. And that's your third degree Taylor. All right? So I made a third degree Taylor centered around pi over 2. Check. Now it says use it to estimate cosine of 2. What do I do? Plug in 2. So we say cosine of 2 equals or is approximated? Approximated by my Taylor at 2, which equals negative 1 times 2 minus pi over 2 plus 2 minus pi over 2 cubed over 3 factorial, okay? All right, so that's my estimate, and sure if it'd be positive or negative, it's okay. So there's my estimate. Now let's talk about the error bound. Does this series alternate? Actually, let's go in there. 2 minus pi over 2, is that positive or negative? It's positive, so this term would be an overall negative, and this one would be positive, yeah? So it seems like this is an alternating series. Do the terms go to 0? The answer is, oh yeah. Why do they really quickly go to 0? Yeah, the factorial. What about 2 minus pi over 2? That's about what? About 0.43. So this is 0.43 to the first. This is 0.43 cubed, which is like 0.064 divided by 6. These are definitely getting small and very fast. And so it is the case that all these conditions are met. So we can say that it must be the case that, let's start with the big picture, and that is the difference between cosine of 2 and what? The Taylor, the third degree Taylor at 2. Excellent. I love that you didn't say pi over 2. At 2 is, which is the same as the true infinite sum S and S sub, it's non-zero terms. I see why you say 4, but it's 2. Okay, so you'd say 2. Is less than or equal to A3, which is, and what, I didn't write it. What's the next term in the Taylor estimate? So do I look at the x minus or the 2 minus? 2 minus. You need a numerical bound. And so it's what? The negative doesn't matter because it's absolute value. We definitely can't have absolute value less than a negative anyway. That would be terrible. So, what? 2 minus pi over 2 to the 5th over 5 times 4. I'm sure that's a very small number. Probably less than 10,000. And that's just two terms. Okay, so far so good? Alrighty, well, let's move along. Okay, so, would you try this? I give you nothing about f of x. I'm not saying you have to sine or cosine or whatever. All I give you is some random facts about it. Write a table based on what I give you. I don't know if you need to write this, but this is the idea you're going to use. Ready? So for this problem, let's see. 1, that's what they're giving you facts about. So the C, which is an x value you're centering around, is 1. All right, so what's f at 1 then? 2. And then what was your next term? What'd you plug in for f prime at C? 3 times x minus c, x minus 1 to the first over 1 factorial. And then f double is 5 times x minus 1 squared over 2 factorial. Did we write a second degree Taylor? Yes, that's through the second part. All right. Try this one. All right, how are we doing? You would think f of 1 would be easiest, but I thought it was the hardest. How do you find f of 1? Yeah, so some kind of fundamental theorem, f at 0 plus the area under the curve from 0 to 1, yeah? And so that's 3 plus, and I assume you did the area under the curve in a triangle kind of way? What's the area? 1 by 10, but I agree, 5. So did you get 8 there? All right, what about f at 1? 10, that's just by reading the graph, I think you'll agree. And f double at 1? Slope, so up 20 over 2, so 10. So did you get an answer of 8 plus 10 times x minus c? X minus 1 to the first over 1 factorial plus 10 x minus 1 squared over 2 factorial. Could I use alternating series error bound there? Sometimes. If I could, then what would X have? I could only use alternating series error bound if X was less than 1, causing X minus 1 to be negative in the pot. You know what I mean? Okay. All right. Otherwise, you'd have to use Lagrange error bound, which is a second method we'll do next week. Yeah, we have time to do this. Okay, so a Taylor series about x equals 0 is made for a certain function with a horizontal tangent at 0, 5, and derivatives of all orders greater than 2 given by this. They're giving you a rule for the derivatives. I know that's weird for people, but you'll get used to it. Does the function have a min, max, or neither at x equals 0? Now, you might be thinking, well, what the cockadoodie? There's a horizontal tangent at 0, 5. So is that at least a good starting place? All right, so I know it's a candidate. Should I go first or second derivative test approach? Why second? Do you have any way of knowing what the first derivative is like? You don't. This rule is 100% for the second derivative and up. I can make no conclusion about the first derivative. So you're going to have to use the second derivative test in conjunction with the horizontal tangent. So what is f double at 0? We got negative 1 to the 0, 0 plus 1 factorial over 4 to the 0, 0 minus 1 squared. Overall, we got what? 1 over 1. So what do we conclude? Concave up, so what do we got there? Min or max? Yeah, f has a min at x equal 0 because f double is greater than 0 and anything else? And f prime is 0. Did they ever tell you that, or did you make a conclusion based on other evidence? Why do you say that? Because there's a horizontal tangent. So you should probably justify why you say that. All right. Give me the. Actually, we're not going to have time. So I didn't get anywhere close to done with these notes. Some of these are on the homework, I think. So I will finish these notes after school, and if you can do the homework without finishing the notes, fine. But it might help to watch. How much do I have left? Am I almost done? It's up to you. It's your call. But I will finish these notes after school, and if you want to watch them this weekend, cool. Well, I guess that's it. Are you ready? Hope to see you again someday. Maybe I'll see a graduation. I don't know. Who's to say? Maybe virtual graduation. I have heard nothing. I don't know what teachers say and how to cancel. I heard 0. I've checked every email I have from the college board. They have said nothing about AP sets. So I don't know if they maybe know somebody, but I don't know anybody. Well, take care of yourselves. Be healthy. Don't forget to wear pants. Bye. Yes. All right.